This is my XXL scale Lego inspired electric monkey bike, and in this video it's time to do some upgrades and modifications. If you haven't seen this running yet, let's take a recap from the last video.
Whoa, the steering's really janky.
I would pay $5 to do this. Way more fun than it should be.
Whoa! Brakes! This don't work. You don't want to sit on studs this side. I've made a list here of things I want to redesign on the bike, so let's go through them. Redesign the pegs. Well, the pegs are just fine, but I want to be able to take the bike on a plane in my luggage so that I can take it to shows. And the pegs are the widest part, and it's because of that aluminium bar that goes right the way through the middle. So I'm going to shorten that bar and make the pegs removable. Wheel hubs, but they don't look much like Lego, so I thought I'd see if I can make some caps that go onto the wheel hubs that make them look more like Lego until I can fully 3D print the wheels. Add lights. Well, adding lights should be quite easy. I can put a headlight and a rear light on. I should even be able to add the brake light in. And it's been a big suggestion by a lot of my viewers. New battery. Well, this battery that I got from Amazon, which I thought was going to be very safe, when I looked inside of it, it didn't look too well made. It sits on this side of the bike about here, and the idea was that I could just take it off and throw it out the way if something went wrong. Well, I'm going to revisit that. I'm going to try and put the battery inside of the rear seat here, and I know I said I wasn't going to do that because it's probably not that safe because my bottom might catch on fire, but I'm going to try it anyway. Add a disc brake. Well, right now I've only got e-braking on the handle here, and it doesn't really do much at all. Brakes just don't work. So I want to put a disc brake on the rear wheel, and then I can lock the rear wheel up and do proper skids. Tricky to know which piece to start on, but I think I'm going to have to disassemble the bike so that I can do any of the work I need to do on it, particularly getting that disc brake in place, because I've got to add it to the back wheel here and then figure out how I'm going to put the caliper on. Right now, to take the rear wheel off, it's wired through the bike frame and up through the chassis and into our electronics housing. So I'm going to add a connector in. So there'll be a connector down through the chassis with an actual connection point for the wheel, so I can disconnect the wheel relatively easily. If you remember from the previous video, this wheel ended up going in the wrong direction.
Damn.
I had to do some various tinkering with the phase wires and the feedback wires to get it to run in the correct direction. Somewhere on here there's a couple of cables, there we go, these two here. This says reset on it. If you join these together, apparently you can teach the wheel which direction you want it to go in. You don't have to mess around with those phase wires. I'm not going to bother trying it because I'm just going to reset everything back to normal and flip the wheel around whilst I'm at it. I'm going to be splicing in this cable about here. To get this one out, back through the chassis, if I can just simply cut it and drag it back through, it's going to be easier. Okay, I'm ready to splice this cable on. Length is probably about there somewhere, but I'm going to make it a bit longer so I can put in a service loop. You can see my previous repairs from where this wheel rotated and ripped all the cables out. There's like 2 repairs in there and a splice. It's a bit of a mess, but hopefully it'll work. While I have this tyre off, I need to fit the disc brake, which goes on this side and goes on there like that. But before I fit the disc brake, I have to figure out what I'm going to do with these hubcaps. I've just removed the front tyre, because this is actually what this little test hub was made for, on that side there like that, and it looks pretty good, doesn't it? Now there is one small problem that my CAD package didn't pick up, and that is that it interferes with this part here. So I've got to make this shallower. That should be fairly easy. So what I've done is come up with a smaller design that sits inside of the metal rim of the wheel, and then a little bit of detail that's going to get glued over the top of that to make it look a bit more like a Lego wheel, and that sits in far enough that the knuckle no longer interferes with it. So that's a pretty good solution. On the other side it's a little bit more tricky just because of that disc brake detail, but again, a few test fits and eventually I got there. It's a tighter fit this side, but that's quite a good thing because I don't want that to float off, and still there's plenty of room for the knuckle to move, and again I'll add that piece of detail to it like so. I've stumbled into a possible problem here, and that is that these disc brakes, I didn't realise that they come with these little spacers when you mount them that sit behind the brake. And the reason for that is that without those spacers, the caliper would rub on the tyre. These bolts might interfere with the suspension strut that sits here. And also here's my little part that I had made up by PCBWay. And that sits on top here, my axle. I mean, the miss is as good as a mile, but oh no, it's not. It's touching down on the bolts. Look at that. So here's an example of having a CAD model that represents the real life model. So I can space the disc brake off there so we can see it stood out further, but we can't see those interferences with the bolts at the moment because I didn't bother adding the bolts in. So one of the first things I'm going to need to do is add those bolt holes into the disc brake and then add the bolts in so we can see where the interference is. Now I have the bolts in place, you can see when I rotate the axle stub the interference with the head of the bolt. This is why it's important to build a complete CAD model. Rather than countersinking the bolt, what I could do is modify this part. Of course, if I was to have it remade, then I would take the corners off like this. But for now I could simply file the corners off, allowing it to rotate freely within the bolts. This section view shows the rear suspension knuckle and axle, and you can see the disc brake and bolts there that look like they will fit inside of the suspension knuckle. However, the disc brake and the knuckle are touching each other, so I'll need to fix that. I've decided to turn the spacers down to about 4.5 to 5 millimeters. They're currently 7 millimeter standoffs, and I think the extra 2.5 mil will make a big difference. Hopefully the caliper won't touch the tyre. I've fitted the new shorter standoffs, and I've also fitted some shorter bolts. I had to cut them down because they were too long with the shorter standoffs. And the caliper looks like it's well clear of the tyre, so with any luck that's going to help quite a lot. Just touches the tops of the bolts. I mean, I can literally now just take the corners off and that would be enough. I need to print the hubcaps for the rear wheels so I can get the wheels back on the bike, and whilst those are printing I'm going to start looking at these lights. The e-bike controller already has a feature to switch the front light on and off, which of course I can use to switch the rear light on and off. However, it doesn't have brake light features, but it should be quite a simple hack to get that working. I have my controller, a battery, a fused switch here, a brake lever, the control panel. This is my lighting rig, so I've got a 48 volt relay, a DC 12 volt regulator which will go up to 60 volt input, and then over here I've got my rear light array, which I'll talk a little bit more about in a moment. So the cables I'm using out of the controller are this permanent 48 volt supply that comes out when the controller is switched on. Then there is this output from the display here from the control panel, and this is actually the front light control output, but it's only a very small amount of current it can switch, so you can't drive the LEDs directly off of it, or indeed the voltage regulator. So that is switching on this relay here, this 48 volt relay, which then switches the power on to the regulator. And then there's another cable in use, which is the brake lever cable, and I'll explain what that's doing in a moment. So let's power up. When I turn on the front light by pressing and holding the plus button, it switches my relay on, which switches the regulator on, which switches my rear light on. And the front light will just come off of this socket as well using the red and brown cable, so that will come on at the same time. A brake lever here which has a little switch in it to tell the controller when the brake's being pressed. It's just a parallel switch, a parallel plug here, so for a front and rear brake. Well, I'm only using a rear brake, so I'm using this other plug to switch a secondary ground on, which will turn on another LED inside of my little rear brake array here. So when I pull the brake lever, you get that second LED comes on and gets brighter. And this little array here is basically a 3D print with a outer ring which is being used for the main light, and then an inner bead LED for the brake light, just held in the middle like so. And then there's a 69 ohm resistor on the ring light and a 10 ohm resistor on the central bead. Let's see what it looks like with the lens in place. This part is printed in translucent PETG material, as is this lens here. However, this one is printed by my sponsor PCBWay, and it's printed in a material called UTR 8100 transparent. And of course it looks so much better than my version. It felt only right that I got this one reprinted in the same material. Take a look at this. It's really good. But I didn't stop there. I also had them reprint my front headlight in translucent yellow. Look at that. It's beautiful. And it really takes me back to the 1980s Lego Space Series when they brought out translucent yellow parts on like the LL928 kit with the blue spaceship. So if you need anything like this printed, then head on over to PCBWay.com. They also do engineering. They did my axles here for the rear of the bike, and they do PCB assembly, PCB manufacture, sheet metal work, amongst other things. So head on over to PCBWay.com and check out their services. I'll leave a link in the description below. The next job to tackle is to remove my support bar through the middle, this aluminium tube, and then I can cut it down to the new length. I'm now ready to assemble the pegs, which are printed in two parts, and I'm going to use some PLA gloop along with some number 6 by 9.5 self-tapping screws. I'm going to use the aluminium tube to clamp the two parts together, and also this Technic bush just to hold it all in place whilst I assemble it. I've got to do this quite quickly, and obviously I need to get them perfectly lined up. Gone off now, so this should be nice and strong. There we go. I'm just going to get a drill and open that out a little bit to make sure the M12 bar will thread in nicely. That's better. Now I can put my captive nut in there, and that's ready to be assembled. The suspension swing arm now goes onto the aluminium tube along with the spacer, and this is now flush. So that's the new width of the bike when it's disassembled without the pegs. So that means it's going to go into my luggage a lot easier when I want to transport it. Now to add the pegs, I passed the 12mm studding through with one peg on one end already. That goes through the aluminium bar, and on the other end I put another peg. I've glued bushing on this peg, which should be on one on that end as well, because this becomes my nut. I've currently taken the nut out from the inside just to make this faster, but that then goes on, screws into place, and that winds the tension up onto these rear swing arms, and that's going to be more than strong enough to support my weight. It's nearly November and it's cold in the workshop, so I've had to put a fleece on. Anyway, let's get this back wheel back into position so that I can see if the caliper is going to work and the disc brake. So I have no idea how I'm going to do that yet. Well, you can spot my first mistake. My hubcap is not going to allow the caliper to go on, so that will have to be redesigned. Getting this brake caliper to line up with the brake and to be attached to the rear swing arm here is quite difficult. And it's basically because I'm being a bit lazy and I'm not drawing this caliper up in my CAD package. Rather than spending the time drawing up the caliper, I'm spending the time trial and error on this bracket here. And actually this is my first attempt and it went pretty well. However, I did have to get medieval on it with a pair of pliers, no blowtorch needed, just to get that caliper to fit in there, but it has actually picked up the brake disc through the caliper. Now, this is a terrible way to mount this because there's so much leverage coming off this arm, and if I hold the caliper on, you can see how much that's going to flex. Now, it's printed super lightweight. It's literally one perimeter just to get the dimensions correct. And I can go obviously a lot tougher on that and possibly even print it in polycarbonate. The better way to do this would have been to take the caliper mounting point off of the rear axle that sits inside of this suspension strut here. So then it would have been a metal bracket straight onto the caliper, and then there'd be less leverage and what have you, and it would have worked just much better. But it's quite complicated to do, plus I'd have to modify the suspension arm. So for now I'm going to keep going with my plastic bracket mounted off of the rear swing arm here. It's a terrible idea and it's probably going to result in a rapid unscheduled disassembly. Here are the iterations of my caliper holder. There's my initial hacked up version. I then made this adjustable version split into two pieces so that I don't have to keep printing so much material. That was a better adaptation of it and slightly different change in the block design. And there's the final design with the correct angle, I think, at the moment. Fortunately, when I made the swing arms, I knew I was going to have to attach a caliper to them, so I put these bolt holes in there which take an M6 square nuts inserted inside. I redesigned my hubcap here to sit back into the wheel so it recesses here, so now it doesn't rub on the caliper. And I've also got rid of those spacers that I turned down, these little ones here. And I've replaced it with a 3D print, which is the spacer and also the retainer for the hubcap. Now we can put the rear swing arm back on. I did change this design again slightly, and that was just to recess the brake caliper down a little bit lower, just to get a bit more bite onto the disc brake. Feels pretty rigid in there. I might just replace this with a black part just to make this whole mechanism disappear, but otherwise that looks pretty good. I've stripped the bike down a little bit because I need to figure out where my cable runs are going for my rear light module and the power supply that's now going to be inside the seat, which would be about here somewhere. So this original part, this 2x8 plate, I actually had a cable run inside of it that goes through here. There's a channel all the way through. You can't really see it on the camera. So I could use that, but I didn't have any side exits for the cables. So I've reprinted the part in two 2x4 plates, which is a lot easier to print. And I've put a side exit in halfway up the plate, just here, for a cable to come out into the seating area. And that should allow me to run cables through here and not be seen. So there's the cables run through these two parts. They're ready to go back on. I've got twin power points on both sides of the bike, so I can have a twin battery setup. And I've got my rear light cable run through the middle there, and all those cables come up and out the top of this piece into the red fuel tank control box. So here's the new plan with the seat. As you can see, I've got this piece on here. Previously, this would have been made up of 3 of these, but now it's a single piece and it's hollowed out inside, like this one here. This is for this side of the bike. The battery now slides inside of the seat. So this is my new lithium battery, which has a BMS in it, a battery management system. So that takes care of the charging and the battery balancing, and also has some kind of load regulation, so you won't go beyond about 20 amps, which is more than enough for the bike. This is a 7 amp hour battery, 48 volts, but I can put another one here and parallel them up so I can get 14 amp hours and get a lot more range out of it. I can't ship lithium batteries on a plane when I take this to a show. So I've got 4 of these 12 volt nickel metal hydride sticks. They also fit in the same compartment, and I can serial these together to give me up to 48 volts at 5 amp hours, which is more than enough for demonstrations. And then the cap on the seat is another part which is hollowed out, and that just sits over the top like that. Obviously these connectors will be tucked up inside, so I think that's a pretty neat system. That's gone back together pretty well, and I've found a pretty novel route for the brake cable, which I've now attached, and it's coming out of the brake up here and routing down here with all the cables. I've brought all the cables to one side and they go through one hole now in my electronics enclosure, but the brake cable also goes up here, loops over the top here, goes down through the chassis, pops out the bottom and into my brake caliper. So it's hidden within the chassis, which is really nice. I've also got the front lights wired up and ready to go. Let's just switch that on. There we go, look at that. That beautiful yellow lens from PCBWay. Does anyone else remember cars in like the 80s? Some of them had yellow headlights. I think it was like European or French imports. I can't really remember. Maybe someone else can let me know in the comment section below. Also, the backlight is looking gorgeous. Going to have to spin the bike around for that. So I've made a little translucent PET-G lens to go over the LEDs there, just to give a little bit of light diffusion, and that seems to work really nice. I don't know whether that's coming out. There we go. And then pull the brake lights on and it gets brighter. Beautiful. Just as a bit of fun, I've also printed myself a rear number plate, M4NT15 Mantis. In the UK, our number plates are made up of letters and numbers, and we can't really decide where they go, so we have to do silly things like using numbers to represent letters. So I've deliberately made it like a UK number plate. And then I've made this little bracket. Technically speaking, in the UK, it should be yellow on the rear, but yeah. So let's look at this, the flex in this rear disc brake holder there. There's my brake cable coming through out of the chassis, down to there. All of this is actually moving, but I won't really know until I get this under proper load and try and stop with me on it. I've got a GoPro mounted here so I can see what's going on with my brake as I pull the brake lever. And I'll be honest, right now it doesn't feel like it's going to stop the bike, but let's give it a go anyway. Oh, I forgot about that terrible steering. Well, it stopped the bike, but it didn't lock the back wheel up, which is a bit disappointing. Let's just try again. Nope. Well, it's definitely stopping the bike much better than just the e-brake, but it's not really biting that disc brake very well. Maybe just need to tension the brake up a bit, the cable, or maybe I need to get more of the disc brake into the caliper. I thought it'd be a good idea to take a little shot in the dark of the light. It's actually very bright, but it's also shines straight up into a big ring on the ceiling. Maybe we should try the clear lens as comparison. Get the clear lens on. I went with a warm light LED, so there's still a bit of yellow in the colour, but it does produce a very large circular ring of light. If you're wondering what happened to my number plate, I fired the bike up a minute ago and gave it a quick whiz round. Whoa, my life. I'm outside, got some gravel. Let's see if this brake's going to lock up and I can do some skids. Skidded! Yay! Woo. It's skidding. Whoa! If only I could actually wheelie in real life. I'm really pleased with the modifications I've made to the bike. However, it does turn out there is a downside to having a brake, and that is that it now feels a little bit safer because I can stop better, so I want it to go faster. There's a 350 watt geared hub motor in the rear wheel, so I could switch out for a gearless motor of say 1000 or 1500 watts. That could get quite exciting. Don't forget, I've now got YouTube membership. So if you want to become a member like Steve Foster, currently my only member and long-time supporter of the channel, you can click on the membership link below. Otherwise, please like, share, subscribe and leave your comments below. Bye! Where is it? No, I need to feather the brake. Okay, I'm going to give up on that.